We investigated two effects caused by alternating between the virtual and real environments. One is context-dependent forgetting. This effect refers to the effect that memories learned in real are forgotten when immersed in a virtual environment, and memories learned in VR are forgotten when removing HMD and returning to reality. The other effect is a source monitoring error. Previous studies indicated that memories remembered in real and VR environments are easily confused, and it would be difficult to discriminate the source of a memory. We hypothesized that the visual fidelity of virtual environments is responsible for these effects and conducted a mixed design experiment. 36 participants participated in the experiment. They learned 10 words in the real environment, another 10 in the high-fidelity virtual environment, and another 10 in the low-fidelity virtual environment. After an interval, they completed memory tests. This is our high-fidelity virtual environment. We created it using photogrammetry techniques. Next, this is a low-fidelity virtual environment created using primitive CG objects and colors. The avatar was the same in both virtual environments. Participants could naturally move their arms, hands, and fingers using a hand-tracking program. The words to be remembered were presented in this way. The readability was controlled between real and virtual environments. The results showed that participants perceived a higher sense of presence in the high-fidelity virtual environment than in the low-fidelity virtual environment. Next, we found no context-dependent forgetting, regardless of the visual fidelity of the virtual environments. A Bayesian analysis strongly supported the negative result, so we indicate that context-dependent forgetting does not necessarily occur, which will be helpful for VR-based education and training. Finally, we found no increase in source monitoring errors based on the visual fidelity of the virtual environments. However, we observed that a quarter of the learned words were misidentified as learned in the wrong environment across all conditions, which was larger than in the previous studies. Thus, we believe that further research is required to clarify the mechanism of the source monitoring errors.